everyone, this is grade 11 review in preparation for our units on heats and rates. So let's start off by talking about the mole. So we're going to look at one relationship in particular, and that is the 1 mole is equal to molar mass. So capital M here is molar mass, and molar mass is always measured in grams. We can use that relationship to use in two different ways to make conversion factors. We can use it as 1 mole over molar mass, or molar mass over moles. Molar mass is found on the periodic table by looking at the atomic mass at the bottom of each element, and we're going to use the formula to figure out how many times we have to multiply that mass for our total molar mass for the compound. We're going to use the conversion factors on the previous slide to get rid of the units we don't want and keep the units that we do want. So we'll be setting up the problem in a particular way to do that. Let's practice molar mass first. So, what is the molar mass of Na2Cr2O7? This would be a great time to pause the video, see if you're able to work it out, press play, and then you can see the solution. Normally I wouldn't show the work here, but I'm going to show the work this time so that you can see how it's done. So molar mass, big M, is equal to 2 times the molar mass of sodium, 22.99, plus 2 times the molar mass of chromium, 52.00, plus 7 times the molar mass of oxygen. Now your values for molar mass might differ depending on your periodic table. I'm using the grade 12 version. So my grand total then is 261.98 grams. Now let's tie in that relationship with moles. So my next practice question is, how many moles are in 15.6 grams of iron 2 hydroxide? If you like, you can pause the video and give it a try on your own. Otherwise, keep watching while I solve it for you. So I always like to set it up the same way. So I look for, what am I looking for? Moles equals, and then what do I have? 15.6 grams. Then I'm going to multiply it by the appropriate conversion factor. So again, I have those 2 conversion factors to choose from. I'm going to choose the one that gets rid of the units I don't want and keeps the units that I do. So I want moles to go on top, I want molar mass to go on the bottom here, so that grams are on the top and the bottom of this equation, which allows me to cancel them. Then I have to look up the molar mass of iron 2 hydroxide, which is 89.85, and I just worked that out the exact same way as the previous problem. So my grams here will cancel, and it will leave me with the answer 0.174 moles, and you can see moles is the leftover unit here. Just a quick mention or preview of significant digits. When I've been given a question here, I've only got one number given, which is 3 significant digits. That dictates how many significant digits I'm allowed to keep in the final answer. Let's try this next question. Oh, my bad, it was the same one. Let's try this next question. How many grams are in 0.25 moles of H2CO3? Again, it would be a great time to pause and try to solve it yourself, and then play while I solve it with you. So again, I'm looking for how many grams in this one. So I'm looking for the mass. So I'm going to set it up. Mass is what I'm looking for, equals. And then what do I have? I have the moles, 0.25 moles. Now I'm going to set up that conversion factor. So I'm going to multiply by one of the conversion factors. In this case, I want mass to be on the top because that's what I'm looking for. I want my 1 mole underneath because I want it to cancel out. Again, I'm going to work out the molar mass. I can just do that on my calculator. I don't need to show that work. 62.01. And my moles will cancel here, which is exactly what I want. And I'll be left with 16 grams. Now, it's not exactly 16 grams. I'm rounding it to 16 because, once again, I'm looking at significant digits here. I have 2 significant digits given, so I want 2 significant digits in the final answer as well. Let's pop over to solution chemistry now. So what we just worked with is if we had a solid amount of substance, how do you work with that solid? But sometimes things are not in the solid phase. Sometimes they're given to us in the solution phase. And solution chemistry works differently. When you have a solution, you don't only have the mass of the solid that you put in there, but you also have the mass of the water. So the two things are now combining. So we have to use different math to work out number of moles. So our first formula is C equals N over V, where C is the concentration in moles per liter, N is in moles and volume is in liters, and that's really important because we want to make sure we have consistent units there. That means if we do have a volume given in milliliters, which is quite common, we do have to convert that into liters. So just a reminder that when we go from milliliters to liters, we want to divide by 1,000 there. So let's try this practice problem. What volume of solution can be made from 0.89 moles of copper 2 hydroxide if the concentration needs to be 0.35 moles per liter? So let's pick out what I know. I have a volume that I'm looking for. I have moles, which is, let's write that as N. N is equal to 0.89. And I have a concentration of 0.35 moles per liter. So my standard formula is C equals N over V. I need to get V by itself, and I need it off the bottom. So I'm going to bring V over. Anytime something goes over the equals, remember it does the opposite math, so it's dividing here. When it goes over the equals, it will end up at the top being multiplied. Now I want, of course, the V to be by itself, so I'm going to kick C out to the other side. It's multiplying, so when I kick it over to the other side, it's going to divide. So my formula looks like this. Then I'm just substituting in. You'll notice I'm substituting everything, both the unit and the number, because this allows me to see what's happening with units here. And then my final answer is going to be 2.5 liters. Again, if I look at the two numbers given, they are both two significant digits here. So again, I'm limited to two significant digits in my final answer as well. So you try this one. I would pause the video and give this one a shot. This time we're looking for what mass of lithium acetate would be needed to make 350 milliliters of solution with a concentration of 0.15 moles per liter. This one is a little trickier than the last one. So again, pause it, see if you're able to work it out, and then come back and play. Let's write down what we know and what we're looking for. So this time I'm looking for a mass, and I have a volume of 350 milliliters, and I have a concentration of 0.15 moles per liter. Right off the bat, I can see that I've got milliliters and liters, so I'm actually going to convert this milliliters into liters for myself. Now I'm asked for mass, but I have C's and V's. I'm going to use my C equals N over V, but I need to solve for moles. Once I have moles, then I can convert back into mass, so I'm going to have to do this in two steps. So let's find moles first. I've got 0.15 moles per liter times my 0.350 liters. Again, you'll see that liters is going to cancel here, leaving us with 0.0525 moles. We can keep extra digits at this point. Now let's tie in mass. We're going back to the first part of our unit where I'm looking for mass. I'm using the moles that I have, and I'm using that conversion factor. So I want mass on top and moles on the bottom, so they cancel. And I'm looking up the molar mass for my lithium acetate, in this case 65.94 grams. So moles here will cancel, and I'm going to get 3.5 grams as my final answer. Again, in terms of significant digits, I have 3 significant digits here. The 0 does count when it's given. And I have 2 significant digits here, but I need to bring it down to the lowest possible significant digits. That dictates the amount of digits I get to keep, so 2 significant digits is where we're going to have it. Our last formula that we need to be aware of is dilution. So we can make a solution from a mass. We just figured out how to do that, but sometimes I'm making a solution from another solution. So I can take a certain amount of solid, dump it into water, stir it up. That's one option, but I can also have an existing solution, add more water to it to dilute it, and that's another option. And this is where I would use this formula, C1V1 equals C2V2. The ones are referring to the original, or sometimes called stock solution, and then the 2's are related to the new solution that I'm going to make. In terms of units, concentrations are still always moles per liter, but here the volume could be milliliters or liters, and that's because when you're working on this, the way things cancel out, you can actually cancel the units so it doesn't make a difference, as you're going to see. So let's practice this question. Again, you can try it on your own first, and then you can come back and see how it's done. I will leave that up to you. So what we're going to do to start is just write down what we know. So how much of a 2.0 mole per liter sulfuric acid solution would be needed to make 500 mils of sulfuric acid solution with a concentration of 0.65 moles per liter? So how much is actually V1? How much of, or what volume of the original solution will I need? The original solution has a 2.0 mole per liter concentration, and I'm going to make 500 mils of new solution with a concentration of 0.65 moles per liter. Couple of tips: the C2 will always be lower than C1 because a dilution is adding water, so you're always making it less concentrated. It can never be any other way. So we're using our C1V1 equals C2V2 formula, and we're rearranging to solve for V1. So we're just going to kick C1 to the other side, and because it's multiplying, it will end up dividing. So our formula will look like this. And let's substitute and solve. So 0.65 moles per liter times 500 milliliters. You're going to see why I don't have to convert my units in a moment here. 0.65 moles per liter. So it seems like there's a problem with the units here, but because moles per liter ends up canceling, you don't have to go to the trouble of converting to liters. You can, absolutely, but you don't need to. So we're getting a number of 163 milliliters here, but if I have a look at the given values in the problem, the lowest given value is 2 significant digits, and I've now just written 3 significant digits. So a couple of different ways I can do this. I have to get rid of this 3, but I still have to maintain the size of the number. So I could write this as 160 milliliters because my 0 doesn't count when I'm producing an answer like this due to rounding, just like I'm rounding right now. So the 0 doesn't count when it's like this. If I gave you the number like 500, those zeros count. When you give it back because of calculating, you do not count your 0. Or that rule sometimes is tricky, so if you really want to be certain, just get rid of the 0 altogether and do a scientific notation. That's another option. If you had converted this into liters, which you can, you're going to get 0.16 liters, and again, that would be 2 significant digits as well. So either way is fine. So you're just going to practice the worksheet online now and make sure you can do these grade 11 skills.